Hi everyone, myself Dr. Lakshmi Prasad, working as an associate professor in the Department of Data Science in Institute of Aeronautical Engineering, Hyderabad. So in this video, I'm going to discuss about different types of distributions. So the very first thing is that normal distribution. So this one discovered by 1733 by De Moivre as an approximation to the binomial distribution. So when the number of trials is large, and this one is going to be derived in 1809 by Gauss, and mainly the importance is lies in central limit theorem, so which is going to be state the large number of independent random variables. So that means just now what I said, there are different types of random variables like binomial, nominal, Poisson distribution, so which is going to be approximate to normal distribution. So example is that, so the human height is going to be determined the large number of factors, so both the genetic and environmental, so which are additive in their effects. So the normal distribution is the one, so which is mainly introduced by the Gaussian, so in 1809. So here mainly this concept is lies on central limit theorem. So it states that the sum of large of independent random variables will approximate a normal distribution. So normally these random variables of different types like binomial, Poisson, geometric, and all. So a random variable is said to be continuous. So if the normal distribution mean value is mu and variance is sigma square, if its probability density function is given by f of x is equal to 1 by sigma into square root of 2 pi e power minus of x minus 2 whole square into divided by 2 sigma square. Here f of x is not same as p of x, so p of x will be 0 for every x because the normal distribution continues, and probability of x less than 2 is given by, so integral x1 by x2 f of x dx. So the random variable is said to be continuous, so where the mean and its variance is given. So in this the probability density function is given by f of x is equal to 1 by sigma into square root of 2 pi e power minus of x minus u whole square by 2 sigma square. Here the f of x is not same as p of x, and p of x will be 0 for every x because the normal distribution is continuous, and the probability of x less than x2 is given by integral of x1 by x2 f of x dx. So the normal distribution will be looks like this, which, and the area under this normal distribution will be considered. Suppose if we want to find the length of the fish, like, so a sample of rock coal in monastery bag suggests that mean length of the fish is this and standard deviation is this one. So assume that the length of rock code is normal random variable. Suppose if we want to catch one of the fish in Monterey Bay, so what is the probability that will be at least 31 in long, and what will be the probability that should be more than 32 inch, and what is the probability that should be lies in between 26 and 29. So a sample of this rock coding monster bag suggests that the mean length of the fish is this one, and then standard deviation is 4 inch. So now I want to find the probability of that length of the fish, which should be at least 31 inch long and more than 32 inch long and in between 26 and 29 inch. So 31 inch long, that should be given as this one, and 32 inch more than this, and in between 26 and 29 like this. And next one is binomial distribution. So here you have to imagine a simple trail with only one two possible outcomes. So that should be either success or failure. For example, tossing a coin, that should be either head or tail, and sex of newborn, that should be male or female, and survival of organism in the region live or die. So whenever a trial is said to be have success and failure, then I'm going to consider this equation binomial distribution. So example, the tossing a coin, male or female, survival of organism and all. So in binomial distribution, suppose that the probability of the success is P and the probability of failure should be Q is equal to 1 minus P. Suppose for tossing a coin, S is equal to head. What is the probability of getting head? 1 by 2. Probability of getting failure is 1 minus P. That should be 1 by 2. So that is 0. That is 0.5. So rolling a dice for getting S equal to 1. That should be probability of 0.1667 is there. So probability of failure should be 1 minus P. So that should be 1 minus 0.1667. So that means 0.833. Similarly, the fertility of chicken egg is given by this. Probability of failure is this one. Suppose the probability of obtaining egg success in entrails. So what is the probability of getting two heads from a coin when we are going to test 5 times? So we are going to have a coin. So if coin is tossed 5 times, so what is the probability of getting head here? So the probability of probability of getting 2 heads. So 1 by 2 of 5. So 1 by 32. So the probability of obtaining X success in entrails is given. So what I'm going to say that is, so I want to find the probability of two heads from the coin when I'm going to toss 5 times. Suppose for all the time I'm going to get it as so the probability of getting two heads is 1 by 2 or 5. That should be 1 by 32. And next one is that Poisson distribution. So here, when there is a large number of trials, but the smaller probability of the success, the binomial calculation becomes impractical. Suppose the example is that the number of deaths from hot kicks in the army is different years. Okay, so the mean number of success of entrails is given by NP. So that means example 64 deaths in 20 years from thousands of soldiers. So when there is a large number of trials, so the small probability of success and binomial calculation becomes impractical. So that should be the problem here. So that is going to be solved through Poisson distribution. So where you can able to solve it, and the mean number of success is given by mu value and into p. Suppose if I am going to substitute the mu value for p and let n to be infinity, so the binomial distribution become Poisson distribution. And this Poisson distribution is given by the equation probability of x equal to e power minus mu into mu power x by x factorial. So the Poisson distribution is applied when the random events in space or time are expected to occur, and deviation from Poisson distribution may indicate some degree of randomness in the event under study. So the investigation of cause may be out of interest. The Poisson distribution mu by n for p So and is given by, so the binomial distribution is going to becomes the Poisson distribution and is going to be set by the equation p of x is equal to e power minus mu into mu power x by x factorial. And the Poisson distribution is going to be applied whenever the random events in space or time expected to occur. So normally the deviation from the Poisson distribution indicates some of the randomness. An investigation of cause may create an interest. So emission of alpha particles. So what is N and what is P? So whether the data follows the Poisson distribution. So is one of the example. So calculation of mu value. So number of particles per interval is denoted as this one. And total I'm considering 14 particles. So in these 14 particles I'm going to calculate the expected value. So that is 2680 into P of x. So that means 2680 into Poisson distribution equation is this one. So like this we are going to calculate the expected value. From this expected value we are going to subtract it from 1, then I'm going to get the observed frequency. So in Poisson distribution I have to calculate the mean value. So the mean should be the number of particles per interval that should be given by this. So 1097 by the 2608. So for these particles, I'm going to calculate this observed value. From this observed value, I'm going to calculate the expected value. So once you got this observed and expected, you have to substitute in the equation. So the number of alpha particles and regular intervals and climate events like this. So these are the different types of distributions in here. So normal distribution. So normal distribution was invented by Gauss in 1809. So mainly this one is going to be used in central limit theorem. So which should be states that the sum of large numbers of individual random variables will approximate a random distribution. And the human height is going to be determined the large number of factors, and the random variable is said to be continuous, and should the equation the probability density function is given by f of x is equal to 1 by sigma into 2 pi e power minus x by 2 sigma square, and f of x is not same as p of x, and this is the normal distribution curve. In the middle of the curve should be treated as the mean value, and next one is binomial distribution. So normally this Bernoulli random variables. So suppose an event is going to consider the two possible outcomes that should be either success or failure. For example, tossing a coin and 6 of newborn and then survival of organism like this. So at the time, the probability of success is given by P and the probability of failure is going to be given by Q is equal to 1 minus P. So if I'm going to toss a coin, x is equal to n, what is the probability of getting tail? So automatically 1 minus s. So that means I'm going to get 0.5. So rolling the dice, so that should be given as probability of success and failure, and fraternity of chicken egg also. And next one is the Poisson distribution. So here this one is going to be used whenever the probability of success and binomial calculation becomes impractical, then the Poisson distribution came into picture. So where here the mean value is going to be calculated, and based on the mean value, so the equation is given by p of x is equal to e power minus mu into mu power x by x factorial. So this is a sample example as well. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.